everybody. I'm Byron Tardif. I'm a program manager with the Azure Websites team. And I'm going to talk to you a little bit about websites, give you kind of like a big overview of Azure. I'm going to do two demos. One of them basically talking about how you can take a website from, a couple hits that maybe you are using with your friends, and then all of a sudden becomes successful and you're dealing with tens of thousands of hundreds of thousands of requests per second. And then the other part is they told me people here are mostly interested in doing development. So I'm going to show you some of the developer-friendly things that we have built into the platform, integrating to continuous integration, that type of thing. Having said that, the first thing I usually try to get is how many people have actually used Azure, any part of Azure. Okay, and out of those, how many have used websites, or are familiar with websites? Okay, so we have 3 people. Okay. So the first question we should be asking ourselves, regardless of what cloud you're using, is why should I develop thinking for the cloud or taking advantage of the cloud? And what these graphs gives you, I know that you probably can't read the numbers, but it's 4 segments of application development. The first one, the one on the bottom, are apps that are either running today or being developed for on-premise scenarios, where you have it running on your own data center, your own set of machines, and that's kind of like the curve of those applications in terms of market share over the next coming years, all the way up to 2020. The next bar over, which is kind of like the purple one, are the applications that are going to be airlifted. And what we mean by that is you grab the application as is, and you basically move it to infrastructure as a service type of scenarios, where instead of running on machines in your data center, it's going to be running on VMs on the cloud. And that gives you an idea of kind of like what that slice is going to be like. The third one up are apps that are being rewritten for the cloud. So this is an app that probably exists today, but it's going to be rewritten to take advantage of cloud features. And then the final one, where we see the majority of the growth, are apps that are going to be net new for the cloud. These are the class of apps that probably couldn't be written or couldn't be created today, but by leveraging the cloud or leveraging multiple pieces of the cloud, they can exist and they become a reality. And this is kind of like why we believe thinking and architecting for the cloud is going to be, just because of the amount of growth that you will be able to take advantage of if you're following these paradigms. The next one is talking about the website service in numbers, and this gives you kind of like an idea of where the website service as a part of Azure is today. We've been live in production for, I think, a little bit over 2 years now. The service has been in one shape or form available, as in, for example, when we had it in a public preview, for close to 3 to 4 years now, and we've been working on it for about 5 years. So this gives you an idea kind of like how the website service is doing in general, and I think those are pretty healthy numbers. I actually think that we have to update that, because we're up north of 300,000 hosted websites and 1.5 billion hits a day. That's kind of a significant number. The next thing I want to show you is, these are just some customers that we highlight out of a list. These are some of the guys that are doing interesting stuff with websites. And I'm going kind of fast because mostly I want to focus on the demos. So I'm kind of like going over the obvious things quickly. So the next thing I want to talk to you is about scalability. When you're developing for on-premise data center, you usually have a very rigid idea of what you want your app to be running on. So you know that you're going to need a machine that has this much RAM. It can guarantee this many IOPS on the hard disk. is going to have this many processors and it's going to be, this size of machine. And usually you're thinking about that in terms of what is going to be your peak load. You need to be able to satisfy that peak load, and it doesn't matter if most of the time you're sitting at 20% of your capacity. You need to think ahead in terms of that peak load. So grabbing just a dictionary definition of what a scalability is the ability of a system to handle a growing amount of work in a capable manner, or its ability to be enlarged to accommodate that growth. So traditionally, what that meant was adding another hard drive, adding another stick of RAM, moving from one machine to another machine that's bigger, that has more processors or faster processor. And when we take this in the context of websites, here's how we think about it. So it's the ability of a system, in this case a website, to handle a growing amount of work. In this case we're talking HTTP traffic, in a manner that it basically doesn't kill the service. So you don't start getting 500s or 400s. You want to keep your 200s up and healthy. So your scaling options are two. Traditionally, this is what you've been doing. You have your software running on a small box, then you have your software running on a medium box, and then you have your software running on a large box. And there's a cap that you're going to hit as to how big is the box that you're going to be able to run your machine on. And you can do this on pretty much any cloud. You basically go from a small instance to a medium instance to a large instance, but you're going to hit a cap as to what is the biggest machine that you can get from Amazon or website or Azure. It doesn't really matter where you're going. And there is a very clear limit to the scalability in that terms, right? You're going to hit that cap. And the other type of scale that you should be thinking of when you're thinking about the cloud is the scale out. So this is the capacity of your piece of software to use multiple machines. The reason why that is interesting is it's a lot easier to go from one machine to 20 machines when you're running in the cloud versus when you're running in a data center. You don't have to requisition those machines. You don't have to pay for the machine to be shipped and plugged in and maintained and all of that. And you can do it on the fly. So if all of a sudden you start getting a bunch of requests, you can add another machine. You can add another machine, right? And the limit or the point where that scale is going to break is going to be a lot higher than growing the machines, right? You can go to 20 instances, or you can go to 40 instances, and if it's written correctly, and if CPU or memory is basically what is bounding you and not the database or some other metric, you should be able to grow pretty much with as many machines as you can add to the mix. So that's what we call architecting for scale and a web app journey towards scalability. And this is kind of like the ramp that we're talking about and kind of like the levels. So the first level is an application that maybe you and your friends are using, and that's around 100 RPS, and that pretty much doesn't matter where you put it or where you host it, it's going to work. Even if you're writing crappy code and not optimizing it for anything, pretty much doesn't matter where you throw it at, it's going to work. The next level, which is kind of like where line of business applications are usually sitting, is around 10,000 RPS. That is significant load, and that's, this should be, if you have a site that is running at that capacity, you should be making money off of it. Like, it's not going to be a site that you're going to be able to run for free. And the final one, which is over 100,000 RPS, it is probably a site that is going to be geo-distributed, meaning you have your customers are not coming from a specific region. They're coming from all over the world. And for the same reason, you're probably going to need a solution that is kind of like all over the world. It is also probably a mission critical site, meaning, for example, if your site is getting 100,000 requests per second and it goes down for a couple minutes a day, you're going to be losing money and you're going to be mad about that. So I'm going to go into my first demo. I usually do break this apart into 3 pieces, but I'm going to show you kind of like the beginning and the end, just because we're pressed a little bit for time. So I'm going to start with a very simple application. I'm going to show you what it does. I'm going to take also advantage of the fact that I'm kind of like showing you how Azure works. So we're going to go through the flow of creating that site and deploying that application. So let me start with okay, I think my machine just hanged. Okay. So how many of you guys have actually seen this UI before? Nobody? Okay, so this is the new portal for Azure. We call it the Azure Preview Portal. The older portal that you probably are familiar with looks something like this. So to give you a really quick overview of this, this is kind of like, this was announced at Build this year. And this is kind of like the direction where we're going, where this is kind of, instead of being web interface, feels more like the whole DevOps story for Azure. And I have a couple sites that I have created over here. And this gives you an overview of, for example, what the site is, what are all the resources that exist with it, kind of like what the metrics, what the requests are coming in. This gives you a lot of very rich information, and you can also customize this to your liking. So for example, I can grab this, and I care about this graph, so I can have it up front, and I can also customize it. So I can do past hour, and now every time I come to the landing page of the UI, I will see this graph that is important for me. So let me go back, see if the other part of the demo is working. Okay, so this is what I wanted to show you. Anybody familiar with Web Matrix? Heard of it? Okay, one person. She's really to do better marketing, guys. So Web Matrix is a free tool that you can download and get started, and it's pretty much a beginner's type of IDE for people that are focusing on websites or web development. And I'm going to show you how easy or how integrated it is. So I'm going to file new. I'm going to start from template gallery. So this gives you a couple, basically a beginner sites or templates that you can use. And what I'm going to do is I'm just going to set up this photo gallery. And I can't hardly see what it says there, but I'm just going to believe that that's going to work. And right off the bat, it gives me the option of integrating it with websites. So I didn't even have to go to the portal. This already has my login because I've logged in before. You log in with your credentials and you can use the portal externally. So Photo Gallery 3 apparently is already taken, but let's do Photo Gallery T-Mobile. That should work. I'm going to this subscription, and I'm going to deploy it on the West US data center. So what's happening now, it's downloading the template. It's going to allow me to run it locally. and then gives me the option to publish it directly to Azure, and I didn't have to do pretty much anything. To give you an idea of what that app is doing, I'm going to kind of like fast forward to what the final product looks like. It is basically a photo gallery where did my mouse go? You can basically upload pictures and share them with your friends. And this is kind of like the template starting site to give you an idea of how you can do this. Now, because this is a starting site, it is designed to be very, very simple, which is not necessarily good when you're architecting for the cloud. One of the biggest problems that it has is that, if I can read what it says there, I don't know if you guys can see that, but it's basically running a SQL CE database. So I'm going to flip back to the slides a little bit. And this is basically the architecture of that site when it begins. The code, the content, meaning your pictures, the session, and the database are all running on the same box. The SQL CE is running in proc with the code and the content. By the way, what this site does, which is really, really bad, is when you upload a picture, it encodes it and saves it into SQL. So every time you load a picture, you need to read it from SQL, re-encode it as a JPEG, and present it. All of that is going to be using CPU time that you should be using to serve requests rather than talk to SQL, deserialize, reserialize, all of that stuff. So I touched on this already, and basically what this means is that this app is stateful. If you were to grab this app and put it on multiple sites and then have a DNS that was round-robining to each one of those, every time you visit the site, you would see a different collection of pictures, because each copy of the site would have its own database and its own pictures. So that's really bad for the cloud. What that means that your only option for this application is scaling up in terms of a bigger machine. So how do we solve this problem? Oh, by the way, before we do that, this is kind of like what the perf looks for that app. So what we did was we grabbed the app as is, deployed it to websites, and loaded it up with a couple pictures. I think we created something like 5 different photo galleries, and each one had around 300 pictures. And basically, every time that you visit a gallery, it would first pull the list of 300 pictures, then do the query to get those 300 pictures from SQL CE, convert them back to JPEGs, and give you the gallery view with all of the different pictures. So running it on a medium box, I would say the acceptable point was when we were only loading it with 2 users. And at that point, we were getting an average response time of around 1.1 seconds per request. And then obviously when we start moving up to, like, for example, 50 users, the average payload went to around 3.48 seconds to 10 seconds. That's obviously a bad experience. If you're going to a website and it's taking 10 seconds to load a single page, you're probably gonna never come back to that. Okay, so moving to the next level, how do we make this scalable in a cloud world, in a cloud architecture? So the structure is the strategy is basically divide and conquer, right? So we want to make sure that content is being served from, for example, blob storage, which is optimized for delivering content at speed. We want to make sure that the database is being served by a proper database that is going to allow us to basically scale out and have multiple copies of the site talking to that database. Takes away all the consistency problems and all of that. We do the same thing with the session. We basically make sure that the session, in this case, is being thrown into SQL. There's another option, you can throw it to cache. We just did SQL right now for the sake of simplicity. And what that does, it basically leaves you with only the code for your site running on the website. Meaning all of the cycles are being used in serving HTTP requests, not in fetching content, not in deserializing, reserializing pictures. And basically that gives you the scale out capability. So here's basically what we did. And once we do that, this is what the numbers look like. So this was maybe 100 lines of code that we had to touch in that application. We didn't do any other optimization, pretty much the minimum amount of work in a couple of hours. And with that, the breaking point starts looking around 1,500 users, and we're getting 19,000 RPS. That is just changing the architecture of the way the site works. Now, this is one of my trivia questions, which is, we were using Visual Studio Test Suite to generate the tests and basically generate the load on the site. And you're going to see two numbers that shouldn't make sense at first glance, right? The number of requests per second from Visual Studio, this is the client side, is around 19,000. The number of requests per second from the website is 1,200. Why is that different, or why is that number so different? I'm sorry?
Is this a load test?
Yep.
Can you ask the question again?
So why are those numbers so different? So from the client side, 18,000 requests or 19,000 requests, and from the server side, only 1,200. Because of the architecture. So basically what's happening is, if you remember, we were talking about presenting a page that had maybe 300 pictures. So one request is going to have to first fetch the file, like the actual gallery page that you're looking for. It's going to have to fetch whatever JavaScript you have running, CSS file, and then do individual requests for each one of the pictures that it wants to show. And because of the architecture, we're now going to blob storage for those requests. So basically, the architecture is designed to reduce the load on the server side. Does that make sense? So there's a bunch of other things that you can do, which we didn't do here, to get even better performance. One of them is you can configure autoscale. One of the things that website lets you do is, based on a given metric for your site, you can configure to scale up or scale down. So this basically is going to save you money. If you know that your peak is going to be at 10 instances, you're not always going to be running your site with 10 instances, basically burning those CPU. You can know that your site is going to be, the metrics that we allow you to scale on are CPU, memory, HTTP queue length, disk queue length, data in and data out. So depending on the application that you're building, each one of those is going to give you which one should be your scale metric. So you can set it based on that, and your website can grow and can shrink without you having to do anything. So this is the typical scenario of my website gets featured on Reddit on the front page, and it's 2 in the morning, and I'm asleep, and it should just handle that by itself without me having to do anything. We didn't optimize the website code, so one of the things that you could do to reduce the load is do lazy loading. Instead of loading 300 pictures at once, you just load whatever is visible. We didn't optimize the SQL, so we didn't add caching and we didn't use CDN, but all of these are things that you can do on top of what we already did. So I promised that I would take you up to 100,000 RPS, and we only hit around 20,000 with that particular architecture. And here's when we go into when bad things happen to good data centers. So let's say that you have your site is running at 19,000 RPS in one particular region in the world, and something happens in that region. It doesn't necessarily need to be your fault, like meaning you pushed the bad code into the website, which can happen. Or it doesn't necessarily mean that something happened to the data center, but just the internet connection, Verizon did something bad and you cannot reach the site. And that happens. So one of the ways to hedge or protect yourself against that is having multiple copies of your site in different geographical regions. Tsunami hits San Francisco, the data center goes underwater. what are you going to do? Your site needs to continue to run, right? So this is kind of like how you hedge against that. And based on what I showed you, these are kind of like, whoops, I don't think you can read that. These are the problems with the previous architecture. So the app, the database, and the data are all local to one region. And when you're running something at 100,000 RPS, you probably want to make sure that that is not the case. You don't want to lose business. You don't want to lose that data if it's running in a single region. And what we want to achieve is active-active replication across 2 different regions. And the benefits should be pretty obvious. You can do bigger scale, lower latency, and higher uptime. I'm going to explain why each. Bigger scale is if you need to reach 100,000 RPS and each one of your stamps or deployments can do 20,000, it means you need 5 of them. Then lower latency, those 5 are going to be in 5 different geographical regions. So you're going to be closer to your customers. The people that actually need to hit the site don't need to, if you have a single copy running in San Francisco and the guy is in Australia, he doesn't need to go across the Atlantic to reach your site. You can have something that is closer to him, let's say in Hong Kong or other region that is closer to him. And then higher uptime NDR, there is a feature called Traffic Manager. It's built into Azure. You can use it. It doesn't cost you any money, which allows you to do 2 or 3 things. So the first one is it does load balancing based on proximity. So an incoming HTTP request is going to be routed to the closest data center or the closest endpoint that you specify to it. So you don't need to do the logic yourself. You don't need to get the request and say, oh, this guy is coming from Atlanta. I'm going to forward him to the West Coast or the East Coast, right? That's taken care of for you. And the other one is if your service, for whatever reason, starts throwing 500s or 400 errors, it can do automatic failover. You can say, oh, this particular stamp is busted. I'm going to start forwarding the request that should be going there to this failback region. So that gives you those 3 things. And based on everything that I explained to you, this picture should be pretty obvious. I don't need to do any explaining, right? Nah, just joking. I'm going to walk you through. So this is basically where we land after doing the level 3 architecture. This is kind of like a multi-region, geographically distributed solution. And let's start with the beginning. This is your website once you've done the cloud-based architecture. So what you have here is you have the website, which basically does the front end. It's serving the requests. We have the blob storage over here, where all your content is stored. We have a queue and a web job. Those are 2 new things that I haven't talked about. What we're doing here is we're implementing a pattern that's called CQRS, which is Command Query Responsibility Segregation. You can look it up later. The main idea is that you can synchronize a service that is geo-distributed across using basically queues or collection of queues. And I'm going to walk you through the flow of how the data is moving through here. Let's say you upload a picture. The picture gets thrown into the queue. Then the web job, which is basically a backend process that is executing behind the scenes, is going to be reading and consuming from that queue. In this case, for the photo gallery, we have the web job doing 2 things. It grabs the raw picture that you upload. It generates multiple versions of it. So we have small, medium, large, extra large, or original size. It does that resizing. It copies it to the content store, which is the blob storage, and it registers it with the database. And it does that across regions. So basically, you're offloading that part of the work from the client UI, and you're throwing it into the backend. And you can, by the way, scale those things individually. The web job basically ends up writing the metadata for the picture into the database and the content into blob storage. When a request for a picture or a gallery page comes in, the website is going to read from the database the metadata, and it's going to read what is the URL for the picture, and it's going to send those back to the client. And then the client can go and fetch the content from the blob storage. And basically what we did is we copied that exact same architecture to a different region. So let's say the one on the left is in East US, and the one on the right is in the West Coast. Now, we need to be able to glue these two things together because they need to present the same content. And we do that through another feature of Azure, which is SQL Azure Sync, which basically does that active-active copying between two different databases. We use Traffic Manager, so each one of these sites has their own unique URLs, but that's not what we're presenting to the users. We have a Traffic Manager URL that does the intelligent routing and geodistribution and failover. And then the other thing that you could add on top of this is CDN, which we didn't do for this, but it's one more thing that you could potentially add to that. So let me show you this thing actually working. Okay, so this is what I have. We have this photo gallery, which is in the north region, and you can read it here in the URL. And then I have this other one that is sitting in the south region. So those are two different copies of the website. Now, I have this other one, which is behind the Traffic Manager URL. And that is right now routing me to the south region because that happens to be faster from where we're standing right now. Since we're here, I'm going to do a demo using my phone. Okay, so hopefully you guys can see this. I'm gonna log in. And you guys need to promise not to remember my super complex password. Okay, by the way, this is going to the north service right now because for whatever reason this one decides that that one is closer. And let's upload a picture. Okay, everybody say hi to the camera. It's uploading and it's right there. And now over here, I'm in the south and I can see it. Now over here, and what happened to it? And there we have it. And kind of to prove that I don't have somebody frantically behind the scenes doing this, you can see that this is coming from blob storage, level 3, storage south, blob. And this is coming from a completely different place. This is coming from the north. So that gives you an idea of kind of like what the architecture looks like, how it performs. You saw there was very little lag. This is tweaked for the demo to do it that way. And basically what I have is I'm polling very frequently. In real life, you would probably have a little bit more of a delay and do more of a batch processing where you're grabbing 10 or 15 messages from the queue instead of one every second. But that gives you an idea of what the architecture is doing. Sure.
Question?
Yep.
So here in the diagram, like I can see the SQL sync is there, which actually copies the metadata to different region.
Right.
So how does the data in the blob store is replicated to other region?
That the web jobs do that. So the web job is copying to the local copy and to the remote copy.
Oh, okay. Okay, got it. Thank you.
Yep.
Is the web job the component which does the load balancing?
No, the load balancing is done by Traffic Manager.
Which is behind that whole?
So let's say your request, when it's like the first request that you're making to the site, it hits Traffic Manager. So your URL was level3.trafficmanager.net. You can obviously put a CNAME or an A record in front of that. And then that one does the decision, oh, I need to go to north or I need to go to south. And then subsequent requests just go directly to that region. You need to go through Traffic Manager again.
So Traffic Manager handles all these components where they are distributed, like
Right.
the content database.
Right. Then the website is always reading from the local copy, right? So the website in south is always going to read content and metadata from the resources that are in the same region as it is. If something happens to something in that region, then all of the requests for that particular region are going to start to fail. Traffic Manager detects that and then starts routing to the other one for the failover scenario. Does that make sense? This one? Oh, CDN. CDN. So, I mean, you can have 5 copies of the website, but CDN can offer you like 30 different locations. So, for example, you can put CDN in front of the blob, and it just reduces the load on that even.
How is that different from the Traffic Manager?
So CDN, the focus of CDN is making sure that you're a lot closer to your customers, right? So even if you have a site in Australia, even if you have a version of this sitting in Hong Kong and your customer is in Australia, it's still far away. If there's a CDN exit node in Australia, it's going to be faster for him.
Okay, but
It's not doing.
routing the traffic through Australia.
No, it's just for the content, right? It's not going to be for. You want to take the.
Yeah, flip the switch up. Sorry.
How about now? Yeah. So the CDN is actually, oh, by the way, I'm Peter. I'm developer on Azure website team, what Baron just presented. CDN is basically for storage, but Traffic Manager is just DNS service. It basically acts just as a name server. So it just changes the way how hostname is resolved to some other hostname in the chain, as in the CNAME chain. CDN is really focused on how the storage, how your content should be located as close as possible to your site and to your customers.
And that's different than the blob storage, or is that?
Here, let me.
Blob storage has only one location. So if you specify that your storage account resides in West US, that's where your content will be. And it's also replicated to another region, but that's for disaster recovery purposes. But for CDN, if you are going for CDN, you are really saying that you want to have your content replicated all around the world, because you will actually serve your content to different customers in different places. So with CDN, you are explicitly saying, I want to have this content replicated, and I would like to have as low latency as possible.
So think about it as another caching layer, right? There's no compute or no transactions going on there. It's just getting you the pictures or the video as fast as possible. There was another question?
Yeah, another question.
So explain it to me. your other diagram, but let's
Mhm.
get rid of us doing it, and I'm going to use media services instead. So Azure Media Services, because you said you're writing the code to do the duplication of multiple sizes of the file. Well,
Right.
Media Services does that for me. So
Media
would
Services
it
does that
exist in
for-
every region that I put it in, or how does that work?
So Media Services does that for you for video, not for pictures.
Okay, well, let's just say I want to upgrade to video now.
Yeah, if you want to upgrade to video, then probably the way to go is you can do it with Media Services. Now, Media Services, the way it works is you upload a file, let's say a large video, and then they will do the processing and generate the multi-streams and multiple audios and do the plexing and all of that. At the end of the line, that processing is still going to end up in a particular region in Azure.
Okay, but
Now-
it will be replicated as well?
No. So let's say the end of the flow is it lands on a blob storage. It begins from
Oh,
a
okay.
blob storage, it ends in a blob storage. And blob storage is going to be in a single region.
Okay,
Now, you can grab that output and you yourself replicate it, or you can put CDN in front of it. Like video is a little bit of a different story, right? But that's the idea.
okay, good, thanks.
Okay, so I showed you basically doing this manually for an app that you're probably going to start from the ground up. You can repeat this exact same thing with WordPress. We have a template in the Azure Gallery, which basically you can go and say click, 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 deploy, and it will basically grab WordPress and replicate this architecture in a single data center. You can go and do another copy of it using all community-provided plugins to read and write to blob storage and leveraging MySQL offered as a service on Azure. So I'm going to skip that just because I don't have enough time to do that. And then the other two things that I have here is, has anybody heard of Have I Been Pwned? Okay, it's a website that is run by an Azure MVP. His name is Troy Hunt. He's basically a security specialist, and he has a database of all of the passwords and, well, not passwords, usernames that have been leaked in security breaches. So you heard about what happened to Adobe or recently to Gmail, and he basically has an index of all of those emails. And you can go into this service, which is running on Azure websites, and you can put in your email, and it tells you if it shows up in any of these lists. And he has basically a white paper that he's written on how he did that. And he claims to be serving 163 million records out of 380,000 queries per minute on top of 163 million records using websites and table storage on top of Blob. And the second one is discussion. This is about a 2-hour long video on how weblogs, the whole multi-site of all of the ASP.NET blogs was migrated from their existing solution to run on top of websites. So that's, I think, 450 different sites that were migrated in one go. And they talk about their architecture, kind of like with the problems that they faced and the solutions that they had. How am I doing on time?
Quick question going back to what you had previously. If
Right.
I have to implement security, passwords, usernames, and other stuff like that, how do I do that with replications across multiple regions?
So you can do that with Active Directory. So if you're storing your passwords in the database, it's going to be taken care of automatically if you're using SQL Sync. Does that make sense? Because at the end of the day, it's just a field in a database, and SQL does the right thing. If you're using another provider, such as an OAuth provider, it's not a problem. And if you're using Active Directory, you can just use Active Directory. I mean, all of the username and transactions are going to be guaranteed by Active Directory.
My question is about SQL Sync.
Mm-hmm.
Is the sync always happening to one central SQL? Or is it, let's say I have 5 different ones, they kind of keep in sync between each other? Like, how scalable is it?
Yeah, you can go, I think, out of the box without talking to support. You can go up to 4 copies. And obviously you have one who is considered like the master or the source of truth. And then all the other ones are going to be replicated to it. The moment the master goes down, then there's an election for another one. If you talk to support, they can boost that number higher, but I think right now it's out of the box is 4.
Thanks.
My name is Matthew. I'm a program manager on Azure Mobile Services. And I realize we're pressed for time, so one, this is going to be one of my fastest mobile services presentations ever, so feel free to stop me, like yell, throw things, whatever. And two, this title is very scary because it says business apps. And I know that turns a lot of people away very quickly. Mobile services is not just for enterprise applications, although we think it is a great option for those. We also have tons of consumer apps that are built on our platform. And it just so happens that a lot of the features that we've been rolling out recently are a little bit more enterprise focused. So that's what I have content for. But certainly I'm glad to take any questions on any of the social stuff, and we'll touch on that a little bit. So the goals are just to kind of give a quick overview. I have heard of mobile services before and or used it. Awesome. And actually the other question is, what kinds of developers do we have in the room? I consider myself or want to be a mobile developer. Okay, a little bit more. Particular platforms, iOS, Android, dangerous stuff, Windows. Yeah, okay. So we'll go over mobile services really quickly. Then we'll talk about some of these new features that I was telling you about and some kind of quick app patterns that people are using to help build out their apps. So to kind of frame everything, and I'll try and make this really quick, we have a demo application that we really like called Field Engineer. Kind of shows a few of the things in action right away. You can go download the sample for this on our website. So what you're seeing right now is a login screen because we do in fact work with Azure Active Directory and make sure that people can log. This is what happens when you try and set up things immediately beforehand. Great. So it's going to yell at me because I didn't log in, and we're going to try another time. Wouldn't be a good demo if it didn't break on you. So this looks kind of empty because it is currently pulling down the data. And what we kind of like about Field Engineer is it's kind of a nice simple app. Basically, this is a to-do list for a worker who's going to customer sites in order to take care of certain tasks. In this instance, we've made the cable guy app. So somebody's going to come and fix your set-top box and then mark the job as complete. So we can drill into our hierarchical data. We can see related items. So I got equipment, great. And I'm going to claim that this job is done because I did such a wonderful job. So I'm going to get the customer to sign off. Submit. And on the back end, we're going to be sending an email to my boss saying, yes, this job was completed, yay. So it's a very simple little app. Not too pretty, not too fancy, but it kind of shows, I'm dealing with login, I'm working with this data. This data is actually being used offline. So actually, I didn't get that thing posted. I have to sync with the server first. And these are kind of the ways that we can show a few features really quickly to kind of, you can build these scenarios really fast with mobile services. So then, the question, well, what exactly is mobile services and how do I use it? And that's a wonderful question. Basically, we're a collection of capabilities that we wrap up and expose via a REST API that's consumable from any mobile application. But in particular, we have first-class SDKs for all your favorite platforms. So the big players, Windows, iOS, Android, as well as plenty of cross-platform solutions. So Xamarin, if you want to write, .NET, C#, and have it go to native apps all across the board, or you want to do something more like PhoneGap, where you're doing HTML, JavaScript. So kind of the big three, features that we boast are data storage. So being able to work with whatever kind of data backend you want to play with, we have support for that, including SQL, Mongo, whatever. Authentication, I mentioned Azure Active Directory. That's definitely more of the enterprise slant. But we also have social providers. So you want your users to log in with Facebook, Twitter, Google, Microsoft account, whatever. We have support for that, and we've actually recently added extensibility to this model, so you can, run with your own provider. So you can have people start authenticating using their GitHub credentials or whatever else. And then lastly, push notifications. Now this one's a little bit special because we actually have a service called Notification Hubs, which is a standalone product in Azure, but it has very tight integration with mobile services. And so this is the way that you can, have your app remind the users that they need to do something. So, hey, you just got a new job assigned, pops up a toast, vibrates, whatever, lets them know. And with all of this, we provide lots of extension capabilities. So, you can hook in and say, well, yeah, I want to log in this user, but I want to make sure that they have permissions to X, Y, and Z first. So all that's done via our compute, which we offer extensibility in Node.js or in ASP.NET Web API. So pending time, I'm going to skip the Get Started demo and give you all homework. It is free to go create an Azure mobile service. Very easy to do. So if you go to manage.windowsazure.com, so this is the current portal, you can create a mobile service very quickly. We'll go ahead and do that anyway. Oh, look at that. Thought I was duplicating. So let's back up just a second. So I'm in the portal that Byron was showing earlier. And I just click New, create a mobile service. Yeah, that'll work. And of course I can create a database to go along with it. But we'll just go ahead and provision a quick .NET backend. I have to remember my password for my database. And I used the wrong credentials. So more demos breaking. But assuming you type in your credentials correctly, you'll have a mobile service in a matter of seconds. And I'll just actually leverage one that I already have because passwords are hard. And from there, you can download your project. So I'm going to do a quick Windows app. Whoops, not what I meant to do. There it is. So now I'm going to just extract out this zip file and load up our good friend Visual Studio. And so what you'll get is a very basic to-do application. You can see this is sort of the foundations of that field engineer app that we built out. And they'll come with two parts. We'll have the client application, so a Windows app using our SDK, as well as a server application. And this is what I can just publish straight up to my mobile service. Very nice tooling built into Visual Studio around this. Of course, if you're using our Node backend, we also have a fantastic in-portal editing experience. And you're certainly able to just publish that up to your mobile service. But you can play around with it. As a standard web API, we'll have basically a to-do item controller, which I need to build my dependencies. But in lieu of time, we won't go deep dive on this. We have some fantastic videos that do kind of a walkthrough of this project. And I encourage you to check those out on azure.com/mobile. But this is kind of the general approach. And the actual SDK itself, what you need to add to your client application, is fairly lightweight. It depends really on what you want to do with it. But in our case, we will, in this fancy new universal app project.
So question for you?
Oh, yeah, go ahead.
So you mentioned that you support Node.js as well. Does that mean the Visual Studio supports that as well?
There is support for Node.js in Visual Studio, but that's not exactly integrated for mobile services. Brief history of time here. We started out with just a Node.js backend, and everything was in portal editing. So basically, we exposed CRUD operations for the different tables that you had in your database. So every time I insert something into my to-do list, table. Here's the logic I want to build around that. So it was very nice and approachable for a lot of new mobile developers. And we've kept that model for the Node.js backend. So we recently GA'd the .NET backend, which was an attempt to kind of, not everybody likes to write Node.js in particular in the enterprise, where you might have a lot of .NET developers lying around. So that was kind of the approach. So it's sort of a split world right now, where Node.js is one experience and .NET is in Visual Studio for now. So that's just kind of the state of things at the moment. But there definitely is, all sorts of fun stuff that they've been doing with Visual Studio to play with languages you wouldn't expect.
So then the only other thing I'll mention is that we're actually scheduled to be about 7:30. So.
Oh, seriously?
Yeah. So.
Oh, that's awesome. Okay.
So you don't have to rush through too much.
Then we're going to do this the right way. I'm sorry, folks. Okay. So many apologies there. I literally thought I had to be done in 5 minutes. Cool. All right, so what's happening here is I'm just downloading all the dependencies that I didn't have loaded up. So, right, no homework for you then, but you should still go and play with mobile services because it is free to try out. No, you cannot actually, and because the way what's going to happen is we provide you a server SDK, which provides a lot of nice tooling that helps you build out the service. But then there's a lot of these extra value-added features that are parts that live kind of in our compiled binaries. And so what ends up happening is we have to you will be uploading the compiled version basically when you publish. So there's a source code. Now we do have integration with source control, a la Azure websites. So there are nice ways of kind of doing, experiences like that. And you can do this when you make commits, trigger a redeploy. So it's a slightly different experience. So I suppose that could be set up, but it's not very common. Okay, so knowing that I have more time now. So we'll take a look really quickly. There's two pieces of information that you need in order to identify a mobile service. You need the mobile service URL and then the application key. This is just kind of a basic, this is the client that I'm using. Now, what you'll notice is that my actual published credentials are currently commented out. The reason for that is that we actually have built-in support. We can debug locally and run our mobile service as is. So in fact, we'll go ahead and start a new instance of the mobile services backend. How are there build errors? Yeah, there are build errors. Oh, look at that. That was me typing over top of. Okay, there we go. So for those playing at home, that's 3 major demo errors that I've had so far tonight. And so what we see here is a full mobile service. We're running with a local, basically SQL database, just kind of running here. And I can actually go in and check out how this is set up. So this basic project has an idea of a to-do item, so some notion of something that would be in my application, and a few methods hanging off of this. And for those familiar with ASP.NET, this is this is a controller.
So this is doing like get and post. What's the difference between this and ASP.NET Web API?
Exactly. So we are sitting on top of Web API. And the reason for that is it is a nice way of kind of setting up these types of controllers that we need for different data objects. But then we've provided some abstractions on top of it, which make it really conducive to mobile scenarios, and to just kind of allow you to integrate a lot of these value-added features. That kind of really help you build out mobile. And in addition, because we kind of know a little bit more about your web API, because we've instrumented this way, we're able to provide a much better degree of support in terms of knowing when things are going wrong with your app and us fixing them, or worst case scenario, letting you know that, hey, either code you pushed up or whatever. What's up?
Can you have part of your service as web API, and let's say I only want notifications? Can I do only notifications in this, or does the whole project need to be mobile service?
So in that example, because Azure Notification Hubs is its own service, you can get away without having to go through this at all. Yeah, so you could just set up your own web API and use Azure Notification Hubs, and you'd be good to go.
Thanks.
So, we can try things out and see that there's some sample data that's being sent back. This is just something that's kind of baked into the project that we're working with right now. But this is a portal web API experience, not as compelling as if I actually show you an app running, right? So let's do that.
For this development environment, is that the same as what you would see in the production environment? So you'd have that little hello world page that lets you click a demo and stuff?
So that poking around thing, that's not turned on when you publish to the cloud, because you may not necessarily want, that guy over there, seeing, everything that your service is offering. So if you want to use a private API for some reason, that would be a concern. So as I said, this is going to be a very simple application here. We have, a simple to-do list, and, I can create a third item and be very happy about that. And it will get served into this local database that we're working with. So far everything is, still local. And as I mentioned before, we can publish this up to the cloud, no problem. But the app itself is just calling the mobile services table endpoints. And I apologize that my window is getting a little bit angry with this resolution. Also, it would help if I was not looking at the phone project there. Sorry, folks, the universal app model throws me every once in a while now. Oh, yep, it did it again. Here we go. So basically, we've kind of got in our page, we're just calling a to-do table.insertAsync. And so the mobile services client is, we're setting it up to define, very simply what table we're talking to. And then we just interact with that object for everything that we need for dealing with this data. And when it comes time to do login, we have very simple methods of login async, and you will get your identity and flow that back to the server. And on the server side, as mentioned, this is a ASP.NET Web API, basically. We actually have what's called a table controller, which is just a child of API controller, but it provides a nice abstraction for your CRUD operations and helping deal with kind of these mobile scenarios. In this case, we're using Entity Framework to talk back to our SQL database, but very simple. This is where I can write all sorts of extensions for actions on my code, and also provide authorizations. So let's say I don't want running code, but let's say I don't want to let anybody deal with my to-do items unless I know who they are. I would give it an authorized level, and yeah, there we go. It's like mobile services authorization level and user. So that's saying, hey, only people who have authenticated are able to use this. So that's kind of the quick whirlwind, me being jumbled about my presentation time, overview of mobile services, getting started with the project. So we'll hop back over to slides now that we've seen that and have been thoroughly confused, and talk a little bit about what we've seen. Awesome. So that kind of approach with that quick start project is what we call the greenfield scenario. Basically by that we mean you didn't have any data to worry about beforehand. We were able to make some nice assumptions about how your schema looked. In fact, we were creating the schema because that was being defined by the project. And we could talk to whatever backend you want. All well and good, except that's not necessarily realistic for every app building scenario, especially when you're dealing with existing data. So, part of the mobile services mantra is, well, simplicity with enablement, and use whatever people are already familiar with. And so in this case, we decided to leverage community piece of AutoMapper to kind of help out here. And so we've made it very easy to, when working with some sort of an existing schema on a database that you already have, to translate that into something that is friendly along the wire. This data transfer object, we by default like to encourage you to include some extra parameters if you're going to use our offline feature, which help enable that in terms of how fresh the data is, and things like that. So it's very easy actually to get started. Take any database that you're working with in your enterprise and start exposing it to mobile. Now, there's a hurdle there though, because existing databases don't necessarily live in the cloud, and I don't necessarily want to open ports for my mobile service to talk back to some on-premises database. We have a solution for that too. It's called BizTalk Services Hybrid Connections. And what's great about this is you spin up one of these in the free tier of BizTalk Services portal, and you will basically just configure the mobile service to know about the hybrid connection. You download this hybrid connection manager onto your on-prem environment, and as long as it has the ability to reach the resource you're trying to access, you're good to go. And so what happens now is I haven't touched my firewall at all, haven't poked any holes there, and my mobile service is now able to address my database by name and communicate port to port in a very clean way. And this is a nice way of kind of enabling these scenarios with existing data. I should point out that Websites also has this feature very well integrated. So we've now got some data made available to our mobile service, and we're very happy. Yep.
So the DTO, do you do any form of processing of the DTO before it goes on the wire, compressing or preparing it to go across the wire rather than, producing the size and so on and so forth?
So, well, certainly there's compression that can be used.
Well, natively through the platform, rather than the application developer doing it.
Right. So there's nothing extra that's needed by the developer in terms of compression. I mean, certainly if you wanted to provide any additional levels of encryption, we're not going to get in your way or anything else. But am I answering the right question here?
I was just speaking in regards to the size rather than the encryption and so on and so forth.
Oh yes, I mean we do have compression baked in already, but I think if you wanted to do more, that certainly is not going to be a problem. Okay, sorry about that. So next we'll jump right into the authentication piece. I mentioned from the client developer perspective, this is as simple as call the mobile service client.login async method. And really all it takes is a few configuration steps. So what I have here are some slides for Azure Active Directory. Similar principles apply for all the service providers. Here, this is the Azure Active Directory pitch. This is fantastic if you're working in you're dealing with an existing Active Directory setup. Azure Active Directory syncs very nicely with existing identity federation. AD stores. And then from the mobile services perspective, we're able to kind of provide a really rich integration with them. So the way that you generally, and you can sub out Active Directory for your identity provider of choice, there are a couple of different flows that are available. One that's very popular is to use the provider SDK, so you get a nice native experience in your application. So in this case, I would use the provider SDK to receive a token from Azure Active Directory. Azure Active Directory knows about my app from the registration process, so there's literally only a few values that I need to copy over, kind of a client ID and an app secret. Azure Active Directory sends that token back to the client application. So that's your invocation in the provider SDK. And then you call the login async method, send it up to the mobile service. Done. User's authenticated. And of course, you can use these tokens for rich graph access, so you can find out more about the user in terms of what their email is, hierarchies, relationships to other users, and things like that. And in some cases, in AD in particular, and a couple other places, you can do delegated access to various resources. And so at this point, the mobile service can do things on behalf of the user. So we'll throw back to our field engineer example. You may have seen, like, when I complete a job, my boss gets an email. Well, what if that email also included a report? So we could, on the mobile service, take the information we know about the job, generate a nice little document, include that signature that we just captured and everything else, and then send in that email to the boss, include the link with the report, or something to that effect. So because we have a notion of this identity, and there is some additional configuration here needed on the Active Directory side for permissions management to talk to SharePoint, for example. But we're able to kind of provide rich access to any SaaS application, software as a service, that we want to integrate, to use as an additional data store. Now, I mentioned offline quite a bit as well. The offline is still relatively new for us. It's currently in beta, but we've had a lot of good feedback on it, and we're getting a lot of that. So, this is the pitch of your app is not necessarily going to always be connected. It's just universal truth. You will find a place that does not have good Wi-Fi, and you can't find a cell signal or something somewhere. And this is crippling to businesses, or even just, I want my app to work when, my users are on an airplane, anything like that. So to solve this problem, we've kind of taken, there's been plenty of offline frameworks before us, many of them from Microsoft. The goal here was not to become, to deal with a monolithic offline platform. The goal was to keep it simple, to make it available across all the different platforms that, we do support, and to kind of deal with these, occasionally connected scenarios head on. So where the assumption is the app does some explicit, management that says, okay, at this time I'm going to push data up to the server. We wanted it to work, with that kind of table controller, which extracted away whatever the data backend was, and be friendly with all of our platforms. Now, because of, I think, the history of offline platforms, I always feel like I have to say, what we're not doing. We're not doing full database-to-database sync here. So we're not taking your entire database, throwing it on a phone. We're not going to, necessarily replace all those great other frameworks too. We address, the vast majority of scenarios, but there's definitely going to be things that, aren't as cleanly supported by offline. And, at that point, we're not going to get in the way if you want to use something else. So it actually doesn't change the model that much, which is really nice. So I mentioned that it's an explicit push-pull. So instead of when we looked at the to-do table in the client code earlier, you would be dealing with what we call a sync table. So slightly different object name, exact same API service. So I would say, on the sync table, I'm just going to insert an item, update an item, delete an item, whatever. But then I would explicitly at some point, maybe via user input via a button, or maybe I'm watching for network connectivity, and as soon as I see that we found a signal, we'll go ahead and send data. At that point, the client app would explicitly push or pull and get the data synced with the server. And in terms of conflict resolution, that's something that we allow you to handle in a variety of ways. So you can define which, if you want to make it client wins, awesome. The server wins, we have lots of additional hooks that you can customize that such that you can even provide excuse me, UI to the user to have them decide what needs to be done. So we're not going to get in your way here. It's whatever works best for your app. You'll know the data better than we will. But in that way, you've got a very simple way of kind of making an offline app work with cloud. So now, just to keep it going, we'll switch gears to push notifications. Now, for push notifications, there's lots of stuff happening. The quick version of how push works is that your client platform, so iOS or Android or whatever, has an associated platform notification service. And when you want to do push notification, you have to get a handle or a channel, however the service calls it, from them. So on your client app, you would say, give me a handle. Great, we have that. So now we know how to address the device. And then we can, send our payload. So, send a toast of, check out this app, open the app, please. Along with a handle, it'll get routed through the platform notification service and sent to the device. Awesome. But then you have to keep them fresh because the handles do change. You have to map those logically to different devices and users and know who you're sending to, who you want to target. This is a major pain. Enter Azure Notification Hubs. So Notification Hubs does complete channel management. So what happens is you send the you register. You get the channel information and you send a registration up to the notification hub. So that includes channel information, so it knows how to talk to the backend. It also includes any sort of segmentation you want to deal with. We call this tags. So I can say that this user is interested in this category of news articles. And so if I want to say, send a push on breaking world news, we'll send that out to just those users who requested it. I could also do specific, pushing to individual users because I know something about them. Even better, we can do, Boolean operations on these. So, I can do everybody who's a Seahawks fan or just happens to be in the Seattle area, send a notification to them. And so this is a really nice way of kind of managing the whole experience and also being able to broadcast to a large number of devices all at the same time. And of course, this is built into mobile services along with the identity story to make push to users super easy. In enterprise-ish scenarios, you'll find that push is a kind of tricky situation because anything going through the platform notification system is going through basically in plain text. And, some people have problems with sending data through Microsoft or Google or Apple via plain text, which is a perfectly reasonable thing to do. So you don't necessarily want to tell somebody, hey, your bank account just got, this much money in it and have that be visible to, everybody in the whole world. So the trick there is to, this is a very simple pattern, but to send a, identifier back to the application, which lets it know to talk to the mobile service, use that identifier to pull the data down securely over our HTTPS channel. Mobile services by default is all HTTPS all the time, just to clarify. So that way you can build this awesome banking app that you were dreaming of and have it be a safe way for information to be relayed to the user and have it notify them without sort of long polling in a great way. The other pattern that we see quite a lot is in conjunction with offline. I want to let the user know that new data is available. So if somebody else edited this item, you should update and see the new data. Last topic, I promise, because I know I've been yakking for quite a while. It's great when you want to really, write all these different platforms, but maintaining 3 separate code bases to cover the 3 platforms is, a challenge. So we definitely have really tight support for cross-platform development. There are 2 kind of players that we've kind of attached to more strongly than others, but not to say we don't support the others. Xamarin is a solution where basically the approach is you write everything in C#, and it compiles down to native. It's just translated to native applications. Very nice experience with Visual Studio. Of course, they have their own IDE, Xamarin Studio. Whenever we get SDK updates out, we get them translated into Xamarin very quickly, which is awesome. The kind of other approach, which is nice, is the Cordova or PhoneGap approach, where you're using basically JavaScript and HTML. So it's not like a native experience, so it's maybe not going to feel like, oh yeah, this is an iOS app and this is an Android app. Great. It's going to feel, a little bit more common, but the nice thing is that you don't have to make any sort of UI adjustments. So it is literally just one code base, as opposed to the Xamarin case where it's C# code, and you'll also have your iOS defined UX and your Android defined UX. So definitely a great support for these. It's certainly a priority for us to be able to help developers use whatever tools they're interested in to build these apps. And the field engineer example that I showed you earlier, we also have an iOS version available, Xamarin.ios, which that sample is fully fleshed out there too, so you can check that out as well. So that's a lot of stuff that I covered. So we walked through the basics of kind of setting up a mobile service. And I apologize for the little bit of a snafu there where I didn't know what I was doing. But then, working with the different data models, dealing with on-prem data, doing our authentication, and offline push and cross-plat. So I realized that was a lot. Microsoft.com/mobile has a lot of really great content to kind of help break that down and let you drill into whatever segments you're most interested in. Of course, I'm glad to take questions now and or via email or whatever. So thanks very much. Appreciate the time.